Coming to this modeling, in last we covered basic modeling about any data project. What is the definition of model? What is the types? And okay, why we need a model also. Next, we are in discussion of levels of modeling. There are 3 levels is available in modeling. First one is conceptual data modeling. Second one is modeling. Third one is physical data modeling. Why it depend upon that particular project and depend upon the domain, these modeling output or what reports we are generating from this modeling will vary. Because when we go for this particular modeling here, for example, whatever we are having instead of the conceptual data modeling, what our modeling team is going to do. Who will do this modeling? This modeling is going to perform by our data modeling team. This particular modeling team is going to identify the business problems, and they will also propose some new system. What are the new experiments? And they will also produce what entities business and what are the attributes involved in the business also. That's what yesterday we discussed. What is the meaning of entity? An entity is nothing but a real world subject area. What is the meaning of attributes? An attribute is nothing but a property of that particular entity.
Welcome to GoToMeeting, online meetings made easy. There are 5 other callers on the call.
Like this, there are multiple entities will be there. These entities, whatever we are having, these entities, whatever we are using here, these entities will be useful for our business purposes, whatever we are doing today. See that those are simply we can call as conceptual data model. Even yesterday I showed you some diagrams or some documents related to this conceptual data modeling. Second step in modeling is nothing but a logical data modeling. What is this logical data modeling? What we are going to do in this logical data modeling? What are the major steps involved in this logical data modeling? How we are going to perform this logical data modeling in any business? This is very useful for any data warehouse which is implementing for our project. Okay. After implementing the conceptual data modeling phase, we are going to get some kind of documents. Those documents are nothing but our basic modeling document, which are going to have entities and attributes information. Based on entities, this logic data modeling is divided into 2 steps. That means one is nothing but a ER modeling. Second one is nothing but a dimensional data modeling. What is this ER modeling? Here ER modeling means entity relationship modeling. Third one is means inside this one. Second one is we are going to have dimensional data modeling. What is the meaning of this entity? How we are going to define an entity, and what is the meaning to create a relationship between one entity to other entity? Let me show you some diagrams. Okay, just we are opening some diagrams related to this logical modeling, how we are going to get those logical modeling and how our modeling team is going to implement that logical data modeling for any of the project also we can see. When we go for any specific project here, I'm showing you some final modeling documents which are created finally after implementing physical modeling actually. But just to understand, I'm showing you the documents. Okay, this document is going to give the overview about the logical data modeling. This is one document which is about a particular subject area in warehouse, because warehouse is going to maintain data in subject areas wise. Here is all or nothing but the each and every, okay, this is one table. Its table name is Hue Organizational Customer is the table name, right? This Hue Organizational Customer is a table here. This particular table will have so many attributes. Actually, this is an entity inside conceptual data modeling. Once to in ER modeling, what we are going to try to identify the relationship between one entity to other entity. Here, this is the organizational customer may have a multiple relationship with the multiple customers. See, this organizational customer is an entity. This entity has a relationship with Hue organizational customer profit and a month summary. The one-to-many relationship means one organizational customer may have a multiple profits, okay, multiple profits in a month based on their business channels. And we also have one more arrow. See here. This is okay showing the representing the one more table, that is the Hue organization customer month summary, okay, snapshot also, and few other more tables also. Just a minute. If you take any table, okay, depend upon our see. Organization customer may take a borrow group, means okay, they may take some loan kind of thing, and okay, he may also depend upon other tables also. See here, a customer is a member, that is organizational customer, means whoever open an account in bank like an organizational customer, they are going to open the organization. But this is a Hue cust is the one table here. This cust table is going to maintain the all customers data. See, this customer entity to there is some multiple relationship with the multiple different entities. See here. This customer is a one. We are trying to identify the relationship between this is a final document. This is other table. There is a relationship between this table to this table. Okay, like this every table. See, customer profit. See here, there are multiple tables there actually. See, from customer table to there is one more table that is called Hue customer credit risk rating history. Means whenever he is applying for a credit card, for example, they are going to see the rating. But already this customer having any credit card in the bank, or if he is already having any type of other account, okay, what is the risk factor is available with this customer? Is he is a default customer, or is this customer is a okay valuable customer to our bank? They are going to identify. They want to identify that. Then customer is on entity. They are going to have a relationship with the customer to other multiple tables also. This is the first step in logical data modeling. Means what our modeling team is going to do in logical data modeling phase is, first they will try to identify what is the relationship between one entity to other entity. Just let me show you some common. See, this is one entity and this is one entity. They will establish a relationship between this entity to this entity. Okay. To establish these all the links and everything, they use a tool called Irwin or Oracle Data Modeler. There are multiple tools there. They are going to use those tools to establish a relationship between one entity, means one table to other table. After finally establishing the relationship between all the tables which are belongs to one thing subject. Okay. Just now what are the PDF I showed you also belongs to involved party subject area. Here involved party means the people who are involved in the business. Whenever we have that involved party subject area, for example, with this kind of diagrams indicating that These are multiple entities. Each and every entity has multiple attributes there. There is a relationship between one to many and many to one. Okay, one to one. There is a cardinality constraint also. So we are here to establish a logical data modeling. The first is ER modeling. Now this is a kind of ER diagram which is indicating what is the relationship between one entity to other entity. This is a kind of logical modeling first step. Second step in logical modeling is dimensional data modeling. What is this dimensional data modeling? What we are going to do in this dimensional data modeling? In dimensional data modeling, whatever the entities available in ER modeling in entity relationship table, each entity will become a one table in warehouse. Got my point? For example, I am telling that these are the entities. Customer is one entity, order is one entity, invoice is one entity, okay, invoice number is one entity, order item is an entity, product is an entity, customer is an entity. Okay, like this we have multiple entities there. When we have multiple entities here, each entity whatever we are taking here, one second. Oh, sorry. Just a minute. I did not observe. One second. Why sounds are coming? Okay, maybe. One second. Let me follow up this. Okay. If we have still issue, then we will check another system. Okay. Sorry, I did not check this pings. Okay, fine. This what are the molding process we are using here? In this particular modeling, we are going to have n number of tables, right? These n number of tables, whatever we are using in these n number of tables, okay, will become means here these n number of tables, whatever we are having here, these n number of tables, whatever we are using, whatever we are following up here, each and every table will have some attributes. These attributes, whatever we have in these entities, will become a columns in our table. Means in logical data modeling, there are two steps is there. One is called ER modeling, and second one is called dimensional data modeling. What is this ER modeling? Means we identify the entities and we establish a relationship, because already entities are identified in conceptual data modeling. Once entities are identified in conceptual data modeling, okay, now we are going to establish a relationship entity in ER modeling. That is okay. But next in ER modeling is means logical data modeling is nothing but a dimensional data modeling. That is very useful one. What is this dimensional data modeling? What we are going to do in this dimensional data modeling? In dimensional data modeling, we are going to perform whatever the entities available here will become a dimension tables, and what are the daily transactional data we are having, that will become a fact tables, and we are also going to have some additional information that is simply we can call as a facts as well. Okay, that is about the simple information related to these tables. Just let me. Now it's okay. Voice are still cracking. Guys means okay, it's still having issue. Yeah, I fixed it. Okay, that is different mission actually. Okay, because this is a different mission. What are the daily class? What I'm teaching different mission. Because okay, that before class actually I'm teaching. For them there is no issue. Okay, okay, opening maybe data set something. Yep. Yes, that one is very good actually. Tomorrow onwards, I will log in. Okay, for your batch that mission only. Yep, sure. Okay, that I'll use that mission only. And okay, tomorrow we'll continue the same link for both the classes. Otherwise, okay, it will be very critical to me to manage it. Okay, multiple classes or multiple links, jumping into that link to this link. Okay, time is wasting. Right. Okay, only today we'll continue this mission. Tomorrow mission will continue that mission only. Here, go for second. Okay. In this one, when we go for this logical data modeling, we simply performing the modeling process with entities and relationship and dimension modeling also. Okay, next step is nothing but a dimensional data modeling. See, ER modeling is not no need to worry by us because ER modeling is also one of the phase, but that will be taken care by modeling people. We are not going to get any ER modeling documents or something. But what we are going to get generally means, as a developer, we need to worry about the dimensional data modeling, clearly about the dimensional data modeling, because once dimensional data modeling is performed, any modeling people, we are going to get some documents and we are going to get some results of the developers. Then developers start implementing those documents. Means you are going to receive some technical specification documents, and you are also going to receive the specification documents, and you are also going to receive some kind of even those PDFs indicate the physical data modeling document. These are terms in data warehouse. Those are nothing: dimensional table, fact table. Third one is fact. What is the meaning of this dimensional table? How we can implement this dimensional table process and everything. Here, a dimensional table is nothing but a table which should have at least one primary key. Simple definition of dimension table is a dimension table is a table which should have at least one primary key and which will give a detailed description about a particular business entity. Means a table which is giving a representing entity and which is creating based on entity. Just see here. We have one entity example. Okay, this entity name is Hugh Customer. Okay, Hugh Cust Credit Risk Rating History. This Hugh Cust Credit Risk Rating History is a one table. This particular Hugh Cust Credit Rating History is on table we have here. This particular table, whatever we have, table is got created from an entity with the name different. Means the same name whatever we have with the entity will become a name in our dimension table. This is a dimension table actually. After implementing entire modeling, this document we are going to get this kind of document, nothing but a we simply going to call as a physical data modeling document. This is having list of all tables. If you see here, this is a physical data modeling document. Okay, this physical data modeling document, after implementing modeling, we are going to get this one. But actually, this physical data modeling document is a document which is going to develop in dimensional data modeling only. This is we are going to implement it, but in dimensional data modeling, we are going to have all these identification of dimension. This is one dimension table. How this is become a dimension table in data warehouse means this is an entity in logical data modeling. Got my point? Okay, first step in modeling, they will identify entities and attributes. Second step, what they did? They are going to establish a relationship between one entity to other entity. And third step, in third step of the modeling, that is especially in logical dimensional data modeling. Inside this modeling process, they are going to convert the dimension tables into, normal entities into dimension tables. Okay, this is a one dimension table. This is having all the attributes, means columns. Like this, they will identify how many number of tables will come into one particular subject area. There may be 50 to 60 tables will be there. If it is simple subject area, there may be 10 tables, 5 tables also will be included into one particular subject area. Okay, that is simple logical data modeling. Inside logical data modeling, second step is called dimensional data modeling. Inside the dimensional data modeling, first definition, that is dimensional table. Dimensional table definition. Okay, this dimensional table definition, which should have at least primary key and which will give a detailed description about a particular business key. That is simple definition. Right, there are multiple different types of what are those? Just let me show you. Okay, dimensional tables are different type of dimension tables available means first one is a conformed dimension table, junk dimension table, fast changing dimension table, role playing dimension table, garbage dimension table, slowly changing dimension table, degenerated dimension table. These are multiple different types of the dimension tables available under modeling. Right. In our project, do we have all these dimension tables? Maybe, may not be. But few of the dimension tables are common if you go into the any other project. But few are depends on domain and depends on the way they created the warehouse also will vary. Okay, we will discuss meaning of conformal dimension with an example for that. Because when we go for interviews, okay, up to now whatever we discuss the topics, okay, those are only fundamentals. But from this point onwards, from the modeling, especially in the modeling also from the dimensional data modeling onwards, it is completely related to the work whatever you are going to do daily basis. The rest of topics are critical parts. Definition of data warehouse architecture, those are just to understand. But the topics whatever we have from this dimensional data modeling, these will direct you whenever you are in this one. See, they simply even they're going to ask a question. What is a conformal dimension table? Can you use some examples in your project? Can you or how many conformal dimension tables is there in our project? And how you create a conformal dimension table data while loading the data into these all the tables? And what type of conformal dimension tables you are following up? Okay, like this, there are so many questions we can expect from the interviews even on these particular types of dimensional tables. Okay. Fast changing, role playing, garbage, slowly changing, and degenerated one also. These are the types of tables available in warehouse while implementing the data into warehouse or while loading the data into warehouse by using this modeling process. Right? That is simply dimensional data modeling. Inside that one, dimension tables. I'm also telling that they are also going to use, apart from dimension tables while creating the model, they are also going to create some other kind of tables which are going to use generally is nothing but a fact tables. What is the meaning of a fact table? A fact table is a table which is going to have two types of information. One is nothing but a composite foreign keys and collection of facts, means which is going to have composite foreign keys and of facts. It's two informations in a particular thing, then simply we are going to call as a fact table. Okay, in any data warehouse, if you see any schema kind of thing, multiple fact tables is there. Depending upon type of fact tables also, there are multiple types is there. What are those multiple types of fact table means? Transaction fact table, cumulative fact table, periodic fact table. Like this we have multiple fact tables also there. Those are directly useful for the business. Okay, for daily transaction. We see, for example, what you may have a type of data we have in fact, what type of data we have in dimensional table. Okay, let me show you some simple You can understand. Whatever you are working on daily basis, for example, morning, all our people are went to one bank and they want to open, right? Once you guys open an account in a bank, okay, application they did, they simply told you that okay, your account is confirmed, you can proceed with the process. If, for example, when they confirm that your account is committed and you can go with that, simply you are getting some welcome kit and welcome kit, whatever you are getting, and okay, you are using those IP pin and every online transactions are for ATM transactions or whatever. Means whenever you open an account, one-time business data, right? Because are you going to open account on daily basis? No. We are going to open account on whenever you open one time, the data whatever we have, just a minute, sorry. The data whatever we have is nothing but an account opening data which is having simple one-time data. But after account is open, every day you are doing some transactions. The transactions whatever you are performing, those transactions are nothing but a daily transactional data which simply going to maintain in fact table. Okay, one-time data is going to be in dimensional tables, and daily transactional data we are going to maintain on fact table. We show some sample data for these two, you can understand. Okay, device or still have an issue. Right. This is a one particular tables data, whatever we have on a one sales project which I worked actually long back. This is the data which is having a different dimensional table. For example, first I am table that is called product. If I took a product dimension table here, it shows all the kinds of products information whatever we have. It shows the product key, followed by product name, followed by product description, followed by category, followed by brand, followed by unit measure, okay, followed by stock and unit price. Like this we have all the kind of data whatever related to products. When you go for this particular product dimension table, this is having this all the table which is having one primary key, that is product or product key, and followed by rest of attributes whatever we have here. My entity name is product. Week one table that's called product dimension table primary key, and which is representing one particular business entity. And one more thing is always they follow the concept descriptive data, which is going to have a descriptive data. Okay, which is also have some numerical data, but most of data will be in dimension tables or descriptive data only. That is simply dimensional table which is having here. For example, now my product ID is 1, product PC, tablet PC. This is okay having a this much RAM and everything. This tablet PC category and brand is SR and okay. This is okay piece wise we are going to calculate and stock amount and everything we have in these fields. For example, but after few days or after few months, the same product is changed. Some features is changed of the same product. While maintaining the same product information in the same table we need to maintain. Okay, to maintain the same table, same product information, if I am taking this one as a primary key, we'll have the same product again. For example, my product ID is 1, right? Now, after doing some business with that, we want to change the product features of the laptop or maybe this particular PC. We want to change some features. Whenever we want to change some features, what are the changes we did? If I am again inserting 1, okay, this one will again one customer ID will accept. If it is a primary key in warehouse, it will not accept, right? Because of duplications. But generally, what we are going to do while implementing a warehouse, we are going to maintain an extra surrogate key. Okay. Apart from these columns, we are also going to insert one more column here. That column is nothing but, for example, prod underscore surrogate key. Okay, this is a one column is there. This particular prod underscore surrogate key is a column which is going to have all unique numbers only. It never duplicates. Like this, we have up to what other records are available. Okay, these data is going to maintain up to how many records is there, those many number of records. Okay, this number is there, but this is unique queue now. After few days, the product got updated. Even though product got updated, because now this is going to maintain as a primary key. The key value here is 151. Product ID is 1. Got my point? Product ID again will be 1, because now the product ID whatever we are maintaining in target, okay, that is not never become a primary key. We are going to maintain other columns as primary keys. That's what. Okay, we don't want to maintain normal, okay, natural keys which are available, which are coming from business as a primary keys in target as a primary keys. We are going to implement in data warehouse an extra column called surrogate key. Now this will become a primary key. Okay, see here, this is becoming a primary key here, and this is a primary key. It never become a duplicate, and again same product. And this one here, instead of 256 MB RAM, they put, for example, 1 MB, sorry, 1 GB RAM. Just okay, some features is changed in this one. Right? Okay, this is that kind of data we are going to maintain in dimensional table. Got my point? Dimension table which should have one primary key and which is going to maintain or which is representing a one particular business entity. Any questions here about definition of dimension table and example? Right. Surrogate key is which we are called the second. Yep. Okay, surrogate key is a key which we are going to in all the dimension tables. That will be a primary key. Means wherever we have a dimension table, if the dimension table maintains okay business data, means then it should have some primary key. That is we are simply going to call a surrogate key.
Okay, I'm having here one question. So what you're saying is if you want to update anything, it will be inserting a new record with the unique surrogate key, right?
Right.
So if I want to pull actually the latest record, say for example you are saying for that product, right? If I just want to pull the properties, so do I need to include the surrogate key also in the where predicates? So I mean to say, if I want to
no, because we don't know. Right. Got it. Because as you because okay, if you want to get the latest record information, we don't. Okay, the data is loading. We are not sure it may be 150. We are going to get based on date only. Because apart from the surrogate key, but to maintain uniqueness data, we are going to implement surrogate key.
So you need to. You are saying actually there
will be multiple keys will be there.
Okay.
But will be in a surrogate key and all columns will be also will be there.
So based on the last updated timestamp or something, we will pull the latest record.
Right. Based on okay latest updated date and latest surrogate key number, and simply get the, for example, we have a okay group by all the records. For example, Acer laptop series number is the 0501. If my laptop series number is 0501, I want to group by that 0501 is the series in group by column. Then I'm going to use latest date is the column to fetch latest record.
Okay, last. So any update will be then insert here.
Right. Here, why I am telling, okay, this inserting and means there are multiple types of implementation we can do while implementing dimension tables. That is, SCD is one type of dimension table. SCD is a little bit one process actual. What is this SCD? I told you in CDC process, okay, in first class. The same kind of process is there in any data that's called SCD. What is the meaning of this SCD? Means slowly changing data.
Okay.
For example, today morning, a new product is launched by Acer. They want to update this product, for example, after 6 or 7 months, okay, based on the response of customers, for example, okay. Now they did not think about, okay, a changing of the product. Based on the response, whatever they're getting, they want to change after 6 months some features about this particular product. If they want to maintain that as a history, there are two things there. If they want to maintain only history, we need to insert the record.
Correct.
If they don't want to maintain history, if they want to maintain only current data, then what we are going to do is, in the same surrogate key record, we are going to update this particular description. Instead of maintaining that one as a separate record, we are going to use same surrogate key only, same product ID. Here that information will be updated. Here this is called SCD type 1. There are three approaches there. Type 1, type 2, type 3. Type 1, we are going to maintain only current data. Current data means today morning we launch a product. That is the current data. After 6 months, for example, the features of the product is changed. Whenever they change the features of the product after 6 months, what is going to happen is they don't want to maintain that record as a separate record in warehouse. They want to update the existing features with the same surrogate key. Only what is going to change, the product name is also changed. They did not change any name. Only the description is changed and date will be changed. Because we have some date columns also there. The date of updation will be maintained. Little bit okay history kind of. But if you want to maintain complete history means just see an example. One customer opened an account in a bank.
Muted.
Okay. That customer, whoever is opened an account in a bank, he opened a morning. After 3 months, he want to close the account. And then after closing an account, he want to open again one more account. Right? I want to track his when open an account, when he want to close the account. And second account also after 6 months he closed. Again third account he opened. Whenever he opening third account, I want to see his history. From when to when he maintained first account. From when to when he maintained second account. Then I need a complete history. That is called
Unmuted.
type 2. SCD type 1 means they are having first record, they are not going to maintain separately one more record. That is depends on our process. Depends on our business, okay, process. We want to maintain type 1 or type 2, that we need to decide. Depend upon our decision, we need to obviously add one more surrogate key, maintain that one as separate record. If you don't want to maintain a history kind of thing, means we want to maintain only current type of data, we can use it. Update this field only, see rest of all the fields will be same. Any other questions? This is about, okay, see, this is one type of dimension table. Even if you store name,
Muted.
okay, store address tables, okay, this kind of data will come and store data. This data we are going to maintain, okay, city, region, everything, tables, right? The simple mean here is this is which is having data store. And even promotion also. Promotion means what kind of promotion they are doing. Promotion kind of thing is nothing but here this is also one dimension table which is going to maintain all the kinds of the market features what they are following up. Like some people will use webmail, some people will use holdings, some holdings, some people will use TV advertisements like this. Okay, what kind of the media they are using to publish to publicity their products. That information is going to maintain on this particular. See, every publicity, for example, we started on publicity. My publicity name is paper printings. Some ID, the promotion ID will be there. Promotion name, promotion media type, which media we want to do, and promotion representative, and promotion cost. From when this promotion.
Welcome to GoToMeeting, online meetings made easy. There are 6 other callers on the call.
For these particular dimension tables, whatever.
Welcome to GoToMeeting, online meetings made easy. There are 6 other callers on the call.
There is some Acer laptop is there. What is happening? Okay, sorry. There is some Acer is there, for example. By saving that one in my TV advertisement, I want to buy, for example, okay. I went to store. I know the product ID also. I told to the store people, this is the product I need. Okay, they give some, for example, feedback form. In the form, I fill that I know this product by through media. That is, for example, telecom media or okay, any media. Okay, I wrote there also, and they told some basic cost, and that store has some store ID and everything, and the product has product ID, right? Means here there are multiple people are involving here: customer, store, and store people who are employees are working on the store also, they are involving. Now, what is this fact table? What type of data we have? Fact table is a table which is going to have a daily transactional data. Means I'm a, for example, I have an ID, customer ID is 1000, right? With my customer ID, I entered the store, I purchased okay some laptop, that particular laptop ID is the 050, and I purchased this one in some store. That store has some ID. The store ID is the 123, and the employee who helped me to purchase this laptop has some ID. His ID is, for example, 457. I purchased that laptop with the cost of 32,000 rupees, for example, and they gave me, for example, some 10% discount. After discount, okay, they give me, for example, that one into the some 27,000 or 28,000 rupees. And apart from that, they also gave me some okay 2 small okay kind of kits as a free for this particular laptop. That each and every product, whatever kits they given to me also, those kits also having okay maybe tool or something. That is also having some ID. Means here, do we maintain any descriptive data in fact table? No, right? Got my points? Because all our numerical data we are going to maintain fact tables. We never maintain descriptive data. But where the descriptive data is there? See, product ID 1 in store 1 in time 1 in purchase by seeing the promotion 24, for example, by seeing promotion he purchased but, and there is some customer ID also there. Means 30,000 came to store and he purchased store product 1. His promotion, he see this particular marketing advertisement through promotion 24, and he purchased 10 laptops and discounted cost this one. Like this we are maintaining. But what is where the product description, product unit price, those details available? It got my point? Dimensional tables kind of data. What is the product description, weight and everything. But fact key, what is the key we got from that particular product table? Even for example, I have a extra one more column is there. For example, column name is customer ID. Customer ID is there. This customer ID is also one column is there, for example. But here the customer ID is showing that some number. I want to deliver this particular product 1 to this customer ID. Where his address and phone number details available in customer dimension table. Means finally when generating any kind of report for any business, we need to fetch daily transactional data from the fact tables and corresponding data, address data or unit price or those kind of data from, then we can generate a just a common example. The phone, right? We took that phone with a different postpaid plan or prepaid plan, whatever. Now we want to use that one. My monthly transactions is, for example, totally 1000 calls I have people. Okay, my friends or everyone, right? They are customer account number, whatever they have in telecom sector. Based on that, they want to generate a bill. They generated. To whom they send this bill? Does the fact table maintain to whom we need to send the bill? No. Based on this ID, whatever we have, we are going to open the corresponding dimension table, that is customer dimension table. In customer dimension table, we can see the customer address. We are going to combine those two tables, generate a report. And one more thing, in fact table belongs to this particular or this particular phone number. There are totally 1000 transactions. That means 1000 total sales or total calls cost. If I see, it shows 2000 rupees. But as per my plan, these 800 calls, 800 minutes is free for me. Where that information is available? In dimension table. Because you took some plan. Your plan information is available in dimension table. Once you get the plan information, address information from dimension table, once you do the calculations, once you get the total data from the fact table, we are going to do calculations there. Total sale, total particular plan amount is total call amount is 2000. Minus 800 minutes amount we need to deduct, and that is the final bill. That final bill we are going to send to customers, right? This is the way we are going to use dimension tables and facts for any business. Okay, that is about the dimension table. In fact, I lost some power here. We'll discuss. Okay, we'll continue. Okay, without any breaks or something, we'll continue exact time and we'll finish exact time. Once the basics is done, we'll go for